run through many data and find me the best value of M and B. Okay, this is the most basic. We call it regression. Okay, so if you do any machine learning, when you do a deep learning, the more complicated, basically, it still fall back to this. Okay, you want to ask a machine to learn from data and determine the value of M and B. Remember what's M or not? Your gradient there. Okay, and B, intercept there. Okay, in machine learning, it's not called intercept because it's not a graph. It's not it's called B because in machine learning we call this bias. That's why it's use a B. So to start TensorFlow, you actually form a graph. Then you just run a session with all the data, and then you get the result. So you can see here, initially here, okay. So you can see here, X and M you multiply, then you add the B, then you become the Y, correct? So the Y is your predicted Y. Okay, so your machine first time you predict the Y, the value can be wrong. Okay, just I ask you to predict what is the height of your friend, you might predict maybe say 1.5 or 1.5 meter. Then your friend say wrong. Then you predict maybe 1.55 or 1.65. Slowly you reduce the error. Okay, so this is what your machine will do. Okay, you actually check the actual Y and the predicted Y, and then you find the error. So the whole purpose of machine learning is to do what? This is to reduce the error. Okay, this is to reduce the error. That's like you teach a kids, teach a picture show the picture of apple. Then you tell the kid this is the picture of apple. Okay, then you show another picture. Then you show another picture. The boy said, "What's this?" Then he said, "This is a picture of a cat." They said, "No, this is not a cat. This is a dog." Then you remember in the future, they said this is similar features. They said this is a cat or a dog. Okay, so this is what the machine will do. You try to reduce the error. Okay. So once you form a graph, okay, this is all the basic operation. You can do add. For example, here you can say TF add 3, 5. That means we don't add 3 and 5. Okay. If you do Python, you just add and you get the result 8. But you do in TensorFlow, you just add, you get nothing because you form a graph, but you haven't execute. You need to use a session to execute. So this is what you do. To get a value, you assign a session. So the session, once you get a session, then you run, you get a value and you print out the result for you. Okay? So basically, the computation graph is a lazy execution. That means you will not do anything until you execute a session. Okay? So TensorFlow, you assemble a computation graph, then you execute the session to operate the graph. So basically like this. You can see the W and the X multiply, then plus the B, the bias, then you get the result. Then from the result, you actually try to reduce the error rate. Okay. Then there's something called ReLU. Later I'll explain to you ReLU. ReLU actually is activation function. It actually stands for rectified linear unit. Okay, so in TensorFlow we have something called variable. Okay, variable is for you to store some parameter. For example, if you do math system, x equal to 10. So x is a variable, store the value of 10. Okay, so this is what you can do in TensorFlow. You can define the variable. Okay, and then in TensorFlow, you actually do a lot of data. So you need to have a placeholder. The placeholder is you're going to store to actually allow you to store some data to it that you can use in the future. Okay, so this is the most important part of any machine learning or AI. Okay, you want to reduce the loss. The loss is what we call error, the predicted versus the actual value. Okay, so always there's a plus or minus. If your prediction there's no error, then the loss is 0. Okay, but if you keep on build a machine when the loss is 0, okay, that means your accuracy is 100%. Then you better be careful. Okay, even human cannot have 100% result there. Okay, in machine learning, this is a phenomenon we call overfitting. That means your data your machine has tried to fit the model exactly like the training data. Okay, then it becomes overfitting. Okay, then you might ask, what's so bad about overfitting? I get a result 100%. Okay, the model only works 100% for your training data only. Okay, but you want to have a model where you have unseen data. In the future, I give unseen data, the model can predict better. This is what we call generalization. So if your model is overfitting, that means your model only works in the control environment, which is the training data. So you do not want that. Okay, So if somebody tell you, I have a machine I train, the accuracy is 99.99999%, then you can say a very smart word. Most probably your model are overfitting. Then he look at you like blur what's happening. Then you know he doesn't know what he's doing. Okay, so once you have the loss function defined, okay, for example, just now we have the actual y and the predicted y. You can measure the error. For example, you can measure by something we call mean square error. Okay, or you can measure by root mean square error. Okay, so this is the error that you actually square up. Okay, then you can actually root it up. So that is a loss. So what is the machine learning model try to do? Is to optimize the loss. Is to reduce the loss. Okay, so I can actually plot my loss function like this. Okay, I want to find where the loss is actually the minimum. Okay, that means the predicted y and the actual y, the loss is the minimum. Okay, so what we call global cost minimum here. Okay, so the way the machine can tweak the value, can tweak the W value, the weight value, is by tweaking it. Is the method we call gradient descent. Okay, so gradient descent is allow you to see whether you want to tweak the value, the W, to the left side or the right side. Okay, so the process you can actually see from if my cost is here, I want to go down to here minimum. So I know if I look at the gradient here, I know I need to go to the left side. If my cost is here, that means I will go down to minimum. If I look at the gradient, then I can actually see where is the minimum. Okay, so this concept is what we call gradient descent. So gradient descent is an optimized function. Okay, how do you reduce the error? So you can see in TensorFlow, every single node there is a gradient. Okay, that means every single part of the node in TensorFlow, it actually tries to reduce the loss. Okay, and do optimization. So you can see there's a gradient here, gradient. So the value has to be tweaked to find the best y, the predicted y. So the predicted y value actual and the actual y, the difference, the minimum. Okay, so that is how TensorFlow works. Okay, so how do you transfer the concept of TensorFlow to TensorFlow.js? Okay, so the TensorFlow.js, the source of inspiration is from this one. Okay, so basically, you can see there's a data, which is the orange data point and the blue data point. You have different type of data, like this, like this, like this. Okay, so you want to train the machine to be able to classify the orange point and the blue point. To us, it's very simple. Okay, orange and blue, different color, easy to classify. But imagine this is the data in the form of numbers and million rows of numbers. You want to feed the machine so they can actually draw a classifier, okay, to classify the orange point and the blue point. So in the future, once you train the model already, if I have a point, then my model will tell me, oh, this actually belongs to the blue, or this dot belongs to the orange. This is the purpose of machine learning. Okay, so then I can have a neural network. Okay, the neural network, you can have multiple layers. You have an input layer, output layer. You can add the number of this hidden layer. You can reduce it, and then for every hidden layer, you can actually increase the node. Okay, so this concept here is to let the student learn how does a neural network perform. Okay, and this is what we call TensorFlow playground. That means from here, okay, sorry, you can add here, add. Then from here, we can actually start training the machine. So the machine, we will see at the beginning, see, you can actually able to very fast classify the blue and the orange. Okay, and then the whole thing here is trained in the browser. That means I do not need to install anything. I do not need to install any TensorFlow library or package, whatever. As long as I have a browser, internet, I can train the machine. Okay, so that is the concept of TensorFlow.js. Now, instead of having a library that I need to install, pick an OS, how about if I just move everything into a browser? Then I can train the model then. Okay, so let's say I stop this, I change to another type of data. You can see there's an orange at both corner, and then the blue data at the other corner. I can train again. So my machine will try to learn how to classify. Okay, see, it's able to classify very fast. Okay, and it's quite accurate. That means if I have a point now drop somewhere around, let's say I have a point drop around here. Let's say I have a point around here. Then I'll know, oh, this point is actually belong to the orange group. Okay, or let's say I have a point dropping around here, then it belongs to the blue group. Okay, so what is the use of this orange or blue? But imagine if it's a cancer cell. I want to know whether there's a cancer cell, is it malignant or benign? Okay, or whether I want to detect whether this person has flu or not, based on data. Then you can classify this. Okay. So that is the source of inspiration. People use this TensorFlow playground to visualize how a neural network works in the browser. Okay. So TensorFlow basically, TensorFlow.js basically is a WebGL accelerated JavaScript. Okay, it works in your browser. Okay, it also works well with the Node.js. So you can develop now all your machine learning model in the browser. Just use the API. Run any existing model. That means if your model been trained, you can run it, or you can actually retrain some model and run in the browser. So the core architecture of TensorFlow.js is basically you have your layer API. So your layers API, good thing is you can just use the Keras model. Okay. So people ask, what is Keras, what is TensorFlow, what is PyTorch, or what is the Theano, or what is CNTK? Yeah, the PyTorch, TensorFlow, CNTK are all different libraries. Okay, but Keras is an upper layer abstraction. You can actually run Keras when the back end is TensorFlow. You can run Keras when the back end is CNTK. You can run Keras when the back end is PyTorch. Okay, but one language you don't care about the back end. So that is good thing about Keras. Okay, so Keras, if you read the book, there's a book by this creator of Keras called Francois. It's a French guy. He actually working with Google now. Okay, so Keras is basically Google actually. Okay, and then under layer of layer API, you have the core API. So the core API will do all the underlying, which is similar to TensorFlow. You can use the TensorFlow safe model. Then under layer, you can actually run everything on top of the browser, which is using the WebGL. And at the same time, you also can run with Node.js. You can utilize or leverage on other processing power like the TPU. TPU is a TensorFlow processing unit. Just now we have CPU, GPU, is it? So you also have a TPU. TPU is a very specific chip which is developed by Google just to speed up the runtime of TensorFlow. So you have TPU, GPU, and CPU. So what's the benefit of running TensorFlow? Basically, you run machine learning or model directly inside your browser. Okay, imagine this is how powerful it is. I just don't need to install anything. I run everything in my browser. So as long as I have internet connection, I can run my model. Okay, so you can just use a WebGL, JavaScript API. If your devices have GPU, you can run the GPU acceleration. So the good thing is, I can develop one application, I can run in multiple devices. Okay, as long as it has a browser. So your desktop has a browser, can run. Your phone has a browser, can run. Your tablet has a browser, can run. Okay, so you take advantage of all this. And then some of the devices have a sensor in it. For example, your phone has a front-face camera. You can use that data from the front-face camera. Okay, so all other resources you can use. Okay, so TensorFlow.js is also very good for educational tools, because when you go to rural area, they don't have so much money to buy high-speed computing. So how do they learn machine learning? They have GPU, whatever. But they have a machine that we have browser. So you actually use it for education tools. Okay, so like I said, TensorFlow.js has two API. We have the core API and then we have the layers API. So the core API basically is to do the underlying concept that's now like I explained to you. You can do form a computational graph. You can define all your tensors. You can do all the operation like multiply, add, or whatever. Then you can actually stack them up into layers. Okay. So basically that's how you use your this TensorFlow API, core API. So how do I get started with TensorFlow.js? Okay. So basically there's two ways. So because it's HTML, you can actually write purely in HTML. So all you need to do is just insert this script here. So you just insert the script and then you write all the TensorFlow code. You can run in your HTML. Okay. If you are using npm Node.js, okay, you can just add like yarn add TensorFlow or npm install. Then inside your code, your main.js code file, just import this line inside there. Then the rest is the basic TensorFlow code. Okay, another two unique thing that TensorFlow.js has is tf.tidy and tf.dispose. Okay, we know that if you run everything in browser, there is limitation. Okay, the limitation is the memory, because you know that nowadays our browser can actually take out a lot of memory, and then your devices has actually limited memory. For example, your phone probably have 4 gig memory, 8 gig memory. Okay, or some devices have less than that. Okay, so you need to actually have a very good memory management. Okay, so the tf.tidy will actually clean up and clear up all the tensors allocated, okay, in your memory, so it will help you to prevent memory leaks. Okay, so generally, if you run data inside your TensorFlow.js, it's better to encapsulate them inside this TensorFlow.tidy, tf.tidy. So for example, this case here, we can define all our data, everything inside tf.tidy, and the operation all inside tf.tidy. So once we execute the program, and then if you close it, everything will be automatically cleaned up from the memory. This is done explicitly. Okay. There's another way you can actually do it is using this tf.dispose. So this is explicitly, you can actually dispose all your tensor found in your main object. Okay? So you can just, for example, you assign a scalar tensor here, then you can say, I want to dispose it. So you can actually clear it from the memory. Okay, the next API that we have is the layers API. So layers API is similar to what we have used in Keras. So basically, you actually create layers of input. You have the input layer, the hidden layer, the output layer. So you stack down up your layers by layers. Okay. So if you use a Keras libraries, so the abstraction is quite easy. One line of code, you can define multiples inside the layers. Okay. So inside, under the hood, every layer will still run the core API. Okay, but it's a upper layer abstraction for you. So the layer will take care of the creating, initializing, all the variables, weight, and then basically makes your life simple. So if you learn the Keras to do deep learning, you can see the Keras actually make your life very simple. You can actually create a model in like 10 lines of code, and you can train already. It's very, very fast. Okay. So basically, I keep on saying layers, layers, layers. What does it mean? Okay. So you do any deep learning or AI, basically this is what you do. You define the input layer, you define the output layer. So must have input layer. Input layer means you must very define what is the data format that you want. Okay. Remember, when you do machine learning, when you do deep learning, AI, whatever, if you don't have data, you cannot do anything. Okay. You are not a magician. You cannot do things without data. Okay. A lot of companies say, oh, I want to do AI, I want to do ML. Then you go ask them, do you have data? Don't have. Then you cannot do anything. Stop already. Full stop. Nothing can be done. Seriously. Until you ask them where you is your data. Oh, I have data all in the form of papers. Okay, then talk about how to translate all these papers data into real data. Okay, that's the most important part. A lot of time, a lot of companies say, I want to employ data scientists or I want to employ machine learning engineer because I see my competitor doing something. I also want to do. Okay? So they employ data scientists come in, then the data scientists say, where's the data? Oh, in the Excel file. Okay, they open the Excel file, it's only like maybe 5,000 raw data. Okay, that's not enough data that you can actually perfect it to get a good result. 5,000 raw data is like a one-day job. You employ a data scientist. What's going to happen to the data scientist for the rest of 19 days per month? Then you say, oh, this data scientist cannot do anything. Well, I employ him, nothing, no work to do. And next month you want to fire him already. Okay, so after you define the input layer, the output layer, you define the hidden layer. So hidden layer, for example, hidden layer 1, hidden layer 2, hidden layer, and then you stack them up inside this layer API. Okay, so generally, this is the general, whether you do it TensorFlow or TensorFlow.js, okay, or TensorFlow Lite, it's the same. Basically, you build a model, you add the first layer, you add the final layer. The first layer is the input layer, the final layer is the output layer. Then you want to train a model. So when you want to train a model, you need to define the optimizer. The optimizer function is to reduce the loss. So you define the loss. What do I mean by define the loss? How do I calculate a loss? The actual y minus the predicted y. Okay, so it can be mean square error, root mean square error, okay, it can be classification error, accuracy, whatever. Then you need to define how you want to evaluate your model and compile your model. So then you train your model with multiple loops, okay, batches with the data. Okay, once your model been trained, then you use it to do prediction. Okay, then you get the result. So this is the general steps. So in the layers API, you can see here, if you use Python, it's quite simple. I just use the keras. I say I want to do a sequential. Then I add how many layers that I want. Then I compile. I have defined optimizer. For example, here the optimizer is SGD. Okay, again, I will use the same joke. SGD is not Singapore dollar. Okay, SGD stands for stochastic gradient descent. And then the loss, you have to define what's the loss. Either it's a mean square error or root mean square error or whatever. Then you define the data. Then you just feed. When you do the feed means you're doing training the data. The import means you want to train 1,000 times. Then after that, once you train the model already, you just do a prediction. That means if I unseen value 5 here, what is the predicted for my y? Okay, you can see this is how you build layers API, and the code is very simple. If you use JavaScript, it's about the same. Okay, you use JavaScript the same. The only thing now is I'm going to run this in a browser. Therefore, I need to import this line here, and the rest is the same. Sequential, add, compile, feed one. And then now you can run this code in your browser. Okay, so this is, if you want to contact me, you can find me in Twitter.